Now there is something called order of a matrix. Order of a matrix is nothing but product between number of rows and number of columns. It is number of rows into number of columns. See, in this matrix A, we have m rows and n columns. We will call m by n or mn here. That is order of a matrix. Now, if they have given a matrix, you know the order. In that case, we can find the number of elements. The number of elements in a matrix is equals to number of rows into number of columns again. Let's say it is 3 by 3 matrix, order 3 matrix. That matrix will be having 9 elements. Clear? This is the basics about the matrix. If they have given a number, order of a matrix, depends on the factors, we can write different types of matrix. For example, they have given like order of a matrix as 3 by 2 or 6. Like maybe they have given you have 6 elements. How many different types of matrices you can form using the 6 elements, right? Different order matrices they are asking. So like in that case, our answer will be like how many factors we have, how many ways we can write 6 as product of 2 natural numbers, that many matrices we can form. Let's say you have 6 elements. The 6 elements you can represent in 1 by 6 matrix. What is 1 by 6 matrix? 1 row, 6 columns. It is a row matrix. 6 by 1 matrix. 6 rows, 1 column, that is a column matrix. 2 by 3, 3 by 2. 4 possibilities are there. Clear? If the number of elements is given, they are asking number of different types of matrices we can form. That will be equals to how many different ways we can write the number of elements as product of 2 different things. That is our answer. Understood? So maybe some examples of matrices we are seeing here. This is matrix A you can take. 1, 2, 3, 4. This is having 2 rows and 2 columns. If number of rows and number of columns are equal, that is known as square matrix. Let's say in this we have B is equals to 1 and then 2. So like here we have 2 rows and 1 column. If there is only 1 column, that is called as column matrix. And third one, let's say C is equals to 2 and then 2. We have 1 row and 2 columns. If there is only 1 row, that is known as row matrix. Clear? So now there is another matrix where the number of rows is not equals to number of columns. Let us take 1, 2, 3, 4, 5, 6. We have 2 rows and 3 columns. This is 2 by 3 matrix, or we can also call as rectangular matrix. Clear? Understood? Now there is something called null matrix. In null matrix, you have all zeros. Null matrix, you can have any order. We will see about these all things later. This is basic of matrix. Give me one moment. Picture quality something changed. Just tell me when you feel better. This is better, right? Sure. Now it's okay, right? Copy this. Copied. So now we are seeing types of matrices. In types of matrix, first one we are starting with row, column, rectangle, square. After seeing square matrix, we will see triangular matrix, diagonal matrix, scalar matrix, identity matrix, right? Somebody please keep open that types and then just let me know if I'm missing anything in that, right? So can I move to the next one? It is types of matrix. Now here we are dividing the types of matrix on basis of order, number of rows and number of columns, right? In types of matrices, first one is row matrix. See guys, if you feel this is boring, I don't have any problem. You solve from matrix or you solve from inverse trigonometry, anything. Clear? If you are okay writing this, you can write. If you feel bored, what you do is like you solve some problem. I should teach this because one student he didn't study it at all. I should not skip, right? So like types of matrices. In types of matrices, first one is a row matrix. So the row matrix is like we say a matrix A, maybe not A, let us use M. M is equals to Aij order M by N is a row matrix if M is equals to 1. In another ways, if the number of rows is equals to 1. Clear? Oh, P is missing, huh? PYPS. See, row matrix na, in a matrix like normal matrix you take of order M by N. If M is equals to 1, right? Any doubt online students?
No, sir.
If the number of rows is equals to 1, right? That is a row matrix. Example of row matrix, only one row you will be having. So like I can say A is equals to 1, 2, 3. We have one row and three columns. It is a row matrix. 1 by 3 is the order. Clear? So now I can also take another example. X is equals to small x, small y. This is a row matrix, one row, two columns. Clear? Maybe you add this one, n is not equals to 1. If n is also equals to 1, that is not row matrix, it becomes square matrix. After row matrix, we are seeing column matrix. Second one. If the number of columns is equals to 1 and number of rows is not equals to 1, that is column matrix. So the example of column matrix we can take 1, 2, only one column, right? But two rows you have, it is like 2 by 1 matrix. I minus I 0. This is again one column but three rows. Clear? After column matrix, we are seeing rectangular matrix. Can I scroll up? Anybody writing this column matrix? Copied. So like a matrix M is equals to Aij of order M by N is a rectangular matrix if M is not equals to N. In other words, if number of rows is not equals to number of columns, that is rectangular matrix. Example of rectangular matrix. In this, we can see there are 3 rows but 2 columns, rectangular matrix. This is also again a rectangular matrix, 2 rows and 3 columns. Clear? After rectangular matrix, we are seeing square matrix. The matrix M is equals to Aij M by N is a square matrix if M is equals to N. Right? So like now we'll say in general M is equals to Aij. The order will be like N by N, right? Order of the square matrix. Instead of writing N by N, we'll write N. For a square matrix alone, we will use this, not for remaining matrix. Right? If it is a rectangular matrix or some other matrix, we use number of rows and number of columns. But if it is a square matrix, we will just use a row or column. We'll mention A is a square matrix of order 3. That is a matrix of order 3 by 3. Clear? Now examples of square matrix. There is a matrix of order 1 by 1. In this only one element you will be having. It is a matrix of order 1 by 1. There is a matrix of order 2 by 2. A matrix of order 2 by 2 is a second order square matrix. And then you will be having a matrix of third order, a square matrix of order 3. This is a square matrix of order 3 by 3 or order 3. We have 4 by 4, 5 by 5, 6 by 6, n by n as well. Clear? See, order of a matrix never be 0. There won't be any matrix where it having 0 rows or 0 columns. That m and n should be natural numbers always. Clear? Now, what we are going to see now is these are all types. on square matrices. You can say that is 5 only in this types. First one we are going to see. Maybe before seeing that type, you should know something called principal diagonal of a square matrix. Clear? So we are seeing that principal diagonal of a square matrix. I am moving this one up. Anybody writing this? Anybody writing this? So principal diagonal of a square matrix. We say, like, let us take matrix A is equals to, maybe we write the definition. The elements, maybe the diagonal elements will be better. The diagonal elements from first row and first column element to last row and last column elements are last column element are principal diagonal elements. See, like for example, I have an n by n matrix, nth order square matrix, A11, A12, A13, and so on, going till A1n, A21, A22, A23, and so on, going till A2n, right? So dot 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 AN1, AN2, AN3 going till ANN. See, like according to the definition, principal diagonal elements are principal diagonally starting from first row, first column element to last row, last column element. It is a diagonal starting from first row, first column going till last row, last column. Like this is the diagonal I am talking about. This diagonal in a square matrix is said to be a principal diagonal, and the elements inside this are principal diagonal elements. Clear? Understood? Right. So like we can write that principal diagonal elements is equals to A11, A22, A33, and so on going till ANN. Mathematically, we can write that principal diagonal elements is equals to AII for all 1 less than or equals I less than or equals N. This is principal diagonal elements, right? So I think you would have studied in school the sum of principal diagonal elements is called determinant. The sum of principal diagonal elements is called trace of a matrix. We will see that one later. Now once we finish the principal diagonal, right? Now we are dividing the matrices again, the square matrices into types. So like now I have a question to everybody who is attending this class. Just listen to me and answer this question. Let's say I have a n by n square matrix. So like the maximum number of non-zero elements needed to make a triangular matrix. It can be upper triangular or it can be lower triangular. What is your answer? The maximum number of non-zero elements are required to form a upper triangular matrix or to form a lower triangular matrix of order n by n. What is your answer? 1. Maximum, dude, not minimum. Maximum. Huh? Think no. Same problem I can also ask in another way. The minimum number of zeros required to form a upper triangular or lower triangular matrix of order n. How many? 3. 1. Think.
3.
Remaining guys, let them think. We will learn what is upper triangular matrix, what is lower triangular matrix. After that, we will see that answer. Anybody has answer online, guys? You guys copied this? Sign it in. After this, upper triangular matrix, I lost the number. What is the number? 5, 6. Previous matrix number, please. Square matrix number is 4. This is 5. 5 you write. Upper triangular matrix. So Mithun, you have answer for the question. I asked 2 questions. See upper triangular matrix, listen carefully. A square matrix, upper triangular matrix na before it should be a square matrix. Rectangular matrix cannot be a upper triangular matrix. In a rectangular matrix, we don't have principal diagonal. Am I clear? Principal diagonal is for only square matrix, right? So like a square matrix of order n is said to be upper triangular matrix if all the elements lying below principal diagonal are equal to 0. Mathematically, we will say a matrix A is a upper triangular matrix if a square matrix M is equals to Aij, n by n is a upper triangular matrix if Aij is equals to 0 for all I is less than j. One moment. I is greater than j only. So like the example of upper triangular matrix, like I am giving you an example for order 2 and order 3 and order 4 as well. Similarly, you can write for remaining as, like maybe you take, this is matrix M1, right? This matrix, upper triangular matrix na 1, 2, 0 and 3. Principal diagonal is 1, 3. Below the principal diagonal, every element should be 0. That is an upper triangular matrix. Similarly, another example we can take, this matrix I am naming as M2. So M2 I am taking order 3. This is 1, 2, 3, 0, 4, 5, 0, 0, 6. Right? So now again, the every element below principal diagonal is 0. In another words, what I said, it is like this 0 if you consider that is an element of first row, sorry, it is second row first column elements. When I is greater than j, aij should be 0. Clear? Understood? Any doubts in this? Right now, if you want more, like M3 is equals, I can write 1, 2, 3, 4, 0, 5, 6, 7, 0, 0, 8, 9, 0, 0, 0, 10. Right? Now you guys have the answer. The minimum number of zeros needed to form a upper triangular or lower triangular matrix will be 1. See, if it is order 2, I said for order n. If it is order 2 matrix, how many I need? 1. If it is order 3, how many I need? 3. If it is order 3, how many I need? 6, right? So if I increase, it is going now. Now that one I will do now. You guys understood? Somebody doubt, online students? One moment, please.
No, sir, can element in upper triangular matrix be 0, sir?
No, it can be 0 as well. Like necessary condition is the element lying below the principal diagonal is 0. The above one may be 0, may not be 0, but like we will say, all is not 0 at the same time. Clear? If all is 0
Okay,
at the same time, that is null matrix. Am I clear?
okay, sir.
So like now, I have asked a problem. You write as a note point, guys. I suggest everybody to write this note. I'll give you 2 note points here. First one is about minimum number of zeros. Second one is about maximum number of non-zero elements we can take. So the minimum number of zeros required to form a upper triangular matrix is equals. Listen carefully. In a upper triangular matrix, if I consider the last row, how many zeros we have? Maybe we start from first row, not last row. First row, how many zeros we have? Necessary, I am asking. You take 3 by 3 matrix. In first row, it is not necessary that there should be a 0. Right? Not necessary, na I can take 0 zeros are needed for row 1. Clear? 0 zeros needed for row 1. So similarly for row 2, how many zeros needed minimum? 1 zeros needed, right? 1 0. For row 3, how many needed? For row 4, 3, right? And so on going till the last row. If I take not n, it is n minus 1. We are going till n minus 1. You can check like if it is order 3 matrix, I need 2 zeros in last row. Order 4 matrix, I need 3 zeros. Now what I am doing, I am adding sum of first n minus 1 natural numbers. What is the formula, guys? N minus 1 into n minus 1 plus 1 by 2 here. So we get n into n minus 1 by 2 is the minimum number of zeros required to form a upper triangular matrix. Now one more question I have. Can you tell me an example of an upper triangular matrix of order 1 by 1? Do we have an upper triangular matrix of order 1 by 1? Huh? There is no element below principal diagonal. See, like every what you say, first order matrix are both upper and lower triangular matrix. Keep this one in mind. Am I clear? Some doubt, online student?
So could you please explain that note first point?
This is the first point. You have some doubt in this?
No, sir, could you please explain it again?
See, like in note point number 1, I am asking here, what is the minimum number of zeros required to form? It can be upper triangular matrix, it can be lower triangular matrix. So like how I am calculating? I am going a matrix of order n by n. I am seeing the first row. is there any element in the first row? Should be 0. It is not necessary to be 0, right? So there are 0 zeros required in row 1. In row 2, there should be minimum 1 0. More than 1 is bonus, but 1 is must and should, right? Second row should have 1. Third row should have 2, and so on. The last row should have n minus 1. Now we are adding 1 to n minus 1 natural numbers, that is n into n minus 1 by 2. Now tell me guys, what is the answer for second one? The maximum number of non-zero elements we can take. The maximum number of non-zero elements are required to form a upper triangular matrix. So Mithun, the maximum number of non-zero elements required to form a upper triangular matrix. Order n, guys. This is upper triangular matrix of order n. If you want, you add that 1 point, please. I am giving for order n. Clear? Somebody saying n plus. That is correct.
So sum
See,
of
like,
n natural numbers.
yes, sum of n natural numbers. Very good. If you take row 1, in row 1, I can keep n non-zero elements. It is not necessary that one element must be 0, right? So row 1 can have n number of non-zero elements. But in row 2, 1 0 is must and should. Remaining n minus 1 can be non-zero elements. In row 3, it is n minus 2, and so on. In last row, n minus 1 should be zeros. So the remaining one, it is not necessary to be 0. Clear? So now, if I see this, it is sum of first n natural numbers. That is n into n plus 1 by 2. If I add 0.1 and 0.2, I'll get n square. Clear? Clear? See, same thing I can write for lower triangular matrix as well. Understood? Going down. So now, Sai Nitin, can you write definition for lower triangular matrix in the same way? Number please, this is 6, 7, 6. Lower triangular matrix. So in lower triangular matrix, 0 should be there above, right? So what I should write? Some doubt anybody in this? Akhilesh? No doubt, right? A matrix, sorry, a square matrix, it should be 2. A square matrix of order n is said to be lower triangular matrix if every element above the principal diagonal is equals to 0. Mathematically, we can write that or a square matrix M is equals to Aij n by n is a lower triangular matrix if Aij is equals to 0 for all I greater than j. See, using this condition, using this mathematical condition, see order one by one, like first order square matrix you take one by one, only one element. You don't have any element which like I greater than j. If no element, na, if we cannot check, by default, it becomes clear. Understood? So now examples of lower triangular matrix.
Sir,
Yes, please.
I is less than J only, no, sir. For upper triangular matrix only, I is greater than J.
One moment. What did I wrote here? Oh, sorry, then I is less than j. I is less than j. So now in example again you can take M1 is equals 1, 0, 2 and 3. Second example M2 is equals 1, 0, 0, 2, 3, 0, 4, 5, 6. One zero 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 2, 3, 0, 0, 4, 5, 6, 0, 7, 8, 9, 10. This is 2 by 2. This is 3 by 3. This is 4 by 4. Right? See, if you want, you can write in lower triangular matrix as well. Same kind of thing. It is not necessary. You wrote in upper, no? Same thing here as well. So like 0 matrix and like matrix of order 1, square matrix of order 1 are the only matrices which are both upper triangular and lower triangular as well. Clear? Can I scroll up? So few note points about these types of matrices. In this first one, null matrix, comma, one moment, all square null matrices and all square or maybe all square matrices of order 1 are both upper triangular and lower triangular matrix. Do you have any matrix like this with you, which is both upper triangular and lower triangular other than square null matrix and order 1 matrix? You don't have, only 2. So the third one, second one, sorry. A matrix is a triangular matrix if it is either upper triangular or lower triangular. Clear? So what is next type, guys? If you studied in school, after triangular matrix, diagonal matrix. Diagonal, I think after diagonal only, no. Scalar is special type of diagonal, we can say. Then can I say diagonal matrices are both upper and lower triangular matrices? That also you add here. Maybe after diagonal matrix you write that. Clear? So number 7 or 8, please. No. Identity is diagonal matrix only, no. Number 7. Okay. So in 7, you guys copied, no? Everybody, whoever writing this. So seventh type of matrix, in seventh type of matrix we are seeing diagonal matrix. So like I want to ask to Mr. Gautaman, can you tell me how many zeros, minimum number of zeros required for a diagonal matrix of order n? If it is a order 1 square matrix, I need how many zeros minimum to make that matrix as diagonal matrix? N into, can you explain that? If your friend is saying you are translating it, I don't want that. If you know, you tell, you explain. Don't know, you accept it, I won't say anything. Don't know. So can anybody answer for this? The minimum number of zeros required to make a diagonal matrix of order n. How many zeros needed maximum? N square minus n. Why? Because there are total n square elements are possible. In that, I can have excluding the diagonal. Remaining all can be zeros. Diagonal also can be 0, but it is not necessary. Clear? Understood? So there are total n square minus the diagonal elements. It is not necessary to 0. So you remove that. N square minus n. Clear? Understood? Some doubt? So like now we are writing the definition of diagonal matrix. So like a square matrix of order n M is equals to Aij n by n is said to be diagonal matrix if Aij is equals to 0 for all I not equals to j. If it is a element other than principal diagonal element, that should be 0. So like example, maybe in general you take m is equals to a1 0 0 0 dot 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 0 0 a2 0 0 dot 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 0. So except principal diagonal elements, every element is 0. That is your diagonal matrix. See the diagonal matrix we can also denote like CIA of M is equals to A1, A2, A3 going till AN. Just we are writing principal diagonal elements. That is another way of representing diagonal matrix. Clear? So some examples of diagonal matrix. One, zero, zero, two. This is second order diagonal matrix. This is third order diagonal matrix. Like that, fourth order will be there. Clear? So here also, if you like, you add that minimum number of zeros and maximum number of non-zero elements.
Sir, this is more doubt.
Yes, please.
Sir, what if the diagonal elements has 0 in it?
Again, it is diagonal. I'll give you an example. Like, since I'm not writing 0 in that, don't think it is a non-zero. They didn't mention it, like, listen, it can be 1, 0, 0, 0, 2. One moment. It is again a diagonal matrix. See, the diagonal matrix definition says excluding principal diagonal elements, everything must be 0. Principal diagonal elements may or may not be 0.
Sir,
If
is a
all
null
principal
matrix a
diagonal
diagonal
elements are
matrix?
0, that is null matrix. Clear?
Sir, whether a null matrix is a diagonal matrix?
Null matrix is a diagonal matrix, null matrix is a triangular matrix, everything. Clear?
Okay, sir, thank you.
We'll write that one below maybe when we are seeing null matrix. So the note number 1 in this. The maximum number of non-zero elements are required to form a diagonal matrix of order n is equals to n only. Maximum number na except principal diagonal elements, everything should be 0. If it is a order n, number of elements in a principal diagonal is n. So that n elements can be maximum non-zero. Now the second point, the minimum number of zeros are required to form a diagonal matrix of order n. See, like here guys, minimum number na in any row you take, there must and should be one element is from principal diagonal that may or may not be 0. Since it is not necessary, we won't consider that one as 0. In every row, there are n minus 1 zeros must and should. You can say column as well. Plus n minus 1 plus n minus 1. We are going till n times you are doing this because n rows. This is n into n minus 1. We can write this one is equals to n square minus n. Clear? Understood? Copy this. Now next I think scalar matrix. Total elements minus principal diagonal. Yep, that is also correct. Next is scalar matrix. Copy this please. If you are writing this, copy and just let me know. So what remaining guys doing, may I know? Trying to solve some problems. Able to solve it. Done. Copied, everybody. Scalar matrix. I forgot, null matrix can be called as scalar matrix as well. Number 8 either. A diagonal matrix of order n is said to be a scalar matrix if all principal diagonals, all principal diagonal elements are equals to a scalar. In bracket you can write k. K can be 0 as well. Huh? See, like now in general, if we are seeing the scalar matrix, this is k 0 0 0 k 0 0 0 k. I have given every element should be same in a diagonal. That is scalar matrix. Right? I think if you attended the morning session, I told about the null matrix as well. Null matrix is both symmetric and skew symmetric, upper triangular, lower triangular, diagonal matrix, scalar matrix. Right? Anything else I left? If you remember anything, you just let me know. Singular, I think singular anyway, yes, singular. Determinant is 0, no? But like, it is not identity. Identity matrix, na, principal diagonal should be equals to 1. In null matrix, it is not 1, no? Right? Now, ninth one is identity matrix. Identity matrix of order n, right? A diagonal matrix of order n is said to be a identity matrix if all principal diagonal elements are equals to unity, maybe 1 also we can say. Identity matrix, scalar matrix also I can write. So like identity matrix of order n, we denote with in. So in we write in this way. Aij is equals to 1 for all I is equals to j. Aij is equals to 0 for all I not equals to j. another way of writing identity matrix. If you need, I2 stands for identity matrix of order 2. So you can write here I2 is equals 1 0 0 1. Then take I3, I3 is equals 1 0 0 0 1 0 0 0 1. Clear? This is identity matrix. Next is null matrix. Can you write null matrix definition for me? See, null matrix, it is not necessary to be a square matrix. It can be of any order. A matrix, just matrix, not necessary to be a square matrix, is said to be a null matrix if every element is equals to 0. Clear? Number 10, I guess. Please write the definition. Null matrix, also known as zero matrix. Null matrix we denote with O. Don't get confused. Outside it is O, inside it is 0. This is a null matrix of order 1 by 1. Scroll. Why? Writing. Incopied. So the remaining guys need some problem. Remaining guys need some problem like this. So tell me the maximum number of distinct elements needed to form a symmetric matrix of order n. Distinct or different? N square. N square. I think it seems correct only. N square. No. E transpose should be A, no? N square is not correct. Think again. See, like rectangular matrix cannot be symmetric and skew symmetric. Matrix should be square, then only we can talk symmetry and skew symmetry. A square matrix of order n is a symmetric, and I am asking the maximum distinct elements we can use in that. Clear? And element itself n square was. If a matrix order n, square matrix, elements itself n square. You are telling more than that. N square plus 3n if you take. More only, no? I didn't remember exactly. I should check. Next class I'll tell. How many we need in 2 by 2? 2 by 2 na, I think we should say A, B and then B, C. 3 needed. Then take n equals to how much you are getting? 3. Working only. 2 into 3 by 2. Seems correct. N into n plus 1 by 2. What about skew symmetric? Non-zero I'm talking, not about 0 in skew symmetric. Everybody copied this? So next is, I should write the example here. O is equals, we can have 0 0. 2 rows and 1 column. These are all null matrix of rectangle type. This is null matrix of square type. Done. So once you copied this, about null matrix, we write few points. I'll dictate. Please write. Hand is paining. Fully writing today. First one is like all square null matrices are upper triangular, lower triangular. All square null matrices are upper triangular, lower triangular, scalar and diagonal matrices. Scalar and diagonal matrix. Anything I left there? No, right? So write 1 point below. That we will write in symmetric and skew symmetric. Below this we write, I think we forgot this one. All diagonal matrices are both upper and lower triangular matrix. I think we didn't wrote this earlier. All wrote down. All diagonal matrices we didn't. All diagonal matrices are both upper and lower triangular matrices. Clear? After null matrix, I think we should read any type I left, guys. If you studied matrices, I am talking to you only. Dear students, any type I left here? Can you see the book and please let me know? Anything I missed here? Singular alone is there. That will right. I think singular alone is missing, it seems. That we will write. Last one in types. Now, last one in types now on rows and then elements, this thing over. Now, hereafter depends on that. We should learn the operations on a matrix. In operation, we should learn addition, subtraction, multiplication. There is something called transpose. Depends on transpose, you have types. Depends on product, again you have types. Right? So in schools, I am stopping here. Remaining we will see in next class. So just one small discussion in schools. Do you guys learned anything about idempotent matrix? Idempotent matrix. Any idea what is that? Involuntary matrix. Nilpotent matrix. Periodic matrix. You learned symmetric and skew symmetric. Do you learn orthogonal matrix? Orthogonal matrix? No, right? A into A transpose equals identity. That is only orthogonal matrix. See, in matrices chapter, JE problem might be, they'll give you the matrix A, they'll ask you A power 2025, A power 2026 like that. We cannot calculate till 2025. What we do is, we do A square, we do A cube, we try to find pattern. Using that we will solve. Pattern like you find A square, few elements will be following, like some elements will be in arithmetic progression, some will be in geometric progression. Based on that, there might be a problem, right? Or else like there might be a problem mixing permutation combination and the matrices, right? They will say let A is a square matrix of order 2. The trace like maybe A into A transpose is this one. Can you tell me how many such matrices are possible like that? Like that you find in JEE mains PYQs. There is something called trace of a matrix and transpose of a matrix. They will say trace of A into A transpose is this much. These are all the elements you can use. Can you tell me how many such matrices are possible? Like this, they'll ask in mains and they'll ask in advanced as well. And then like in matrices, important is types of matrices and properties of all these matrices. If we know them well, we can solve matrices problems. If you see that PYQs of JEE mains, mainly either on the pattern a square, a cube, a power 4, that will be there, or mixing, permutation and combination will be there, or maybe on trace, or maybe on trace, I mean trace, and maybe on symmetric, skew symmetric is important. That they will ask. Clear? So like again I am announcing, if you want class on Sunday, whatever concept you want, please do let me know. It is like first come and first serve. If you come earlier, I'll teach to you only. If you are coming late, your doubt or your concept may not be teaching at that time. So you text me what concept you want. You want chapter 1, chapter 2, you want something from 11th grade. You have some doubts in some book, some reference book, can bring them. But before bringing them, please let me know you are coming at that time, so that I won't tell to some other student. Clear? Am I clear? So now tell me, anybody need that class Sunday? Offline or online? Any concept you want? What concept? See again, in 1 hour or 1 hour 20 minutes, I cannot teach entire conics. Leave conics, I cannot teach entire circle. So you have to be what I can teach in 1 hour, that much I can teach. If you are bringing sir conics, I didn't attend at the class, please teach me conics. In 1 day or 1 hour, we cannot learn full conics. Clear? So if it is a concept in one chapter, if there are problems on the chapter, that I can help. Full chapter, you should come 2 or 3 Sundays like that. You have sent anything, anybody? You're saying something? Complex numbers, full chapter, or any concept. You maybe day after tomorrow you will come, no? You bring the list, what and all you want. You just give me them. I'll go through that and you can come Sunday. Anybody else want complex numbers? Not from scratch.
Yes, sir.
Not
Yes,
from
sir.
scratch.
Yes, sir.
See, like it is not from scratch. I won't teach from the basics. Right? Anything else? I'll let you about my availability timing before 1 day. Please text me about that concepts. Anybody else? Sai Nitin, where is your friend Aditya? Not there. You are all from same school, right? Which school? Different school. You are all from same school. Which school? Mahatma. Aditya is from Delhi Public School is there here, ah? Okay. Let us mark attendance, guys. Please don't leave. If you leave, I'll mark absent for you. Dear online student, please respond if your name is there. Ayyo, so they are leaving. Don't leave, please. Please respond if your name is there. Aditya K is there online. Aris is there online. Aris. Afa is there online. Ajay is there online. Offline. Ajay. Ajit V is there online. Akhilesh S is there offline. Present. Arun Bharati. I think she.
Sir, online.
Gugan S.
Online, sir.
Okay. No. Your name comes, you respond. Hariharan J.
Yes, sir.
Hari Krishnan I.
Yes, sir.
Harish M is there offline. You are Harish M. Why you are not regular? Oh, you changed. Harish Kumar S. Present. Harivarshan S. Jivi. Who's Jivi? You are Jivi. You will come online. First time you came offline. Okay. Jagadish V. JS Arvanan. Jeevataran. Jeevatarun or Taran? Taran, Jeevataran, okay. Jose is not there. Kirti Shri.
Present, sir.
Loga Prasanna Ganapati. Oh, okay. You told your name is Loga. Only half you told. Lohit. Mithunes. You are Mithunes. Mohammed Saifuddin Amir. Mohammed Saifuddin Amir.
Present, sir.
Okay, marked. Muthu Selvam T. Muthuvel V. You are texting me in MS Office Teams, MS Teams. You only know hi, sir. Why? NS Ajay Khanna.
Present, sir.
Naresh Balachandran. Naresh Balachandran not there. Nakshatra SS.
Present.
Padma Vinita.
Present, sir.
Pranav Lakshman MG. R Sai Nitin. Ritika T.
Present, sir.
Roslyn.
Present, sir.
Don't know how to pronounce. What is this name? Not there. Roslyn only there. Shabarinathan K. Okay, you are Shabarinathan. Shabarish Veeranan. Shabarish Veeranan. Absent. Sai Visagan. Not there. Santoshni.
Present, sir.
Santosh M. Gautaman. Shivaganesh M.
Present, sir.
Shivakumar TS. Shivashantos S.